Hello. Okay, welcome back. So, we have a quadrio. Alright, so I'm gonna start just with, here's a unit circle, okay? Fuck. Can you write up the exercise? I don't know. Once I finish the rest of the other 7 million problems in the queue, and also, I think I'm really behind on checkoffs too, actually, now that I think about it. I was gonna do that before the stream, and then I failed. Because setting this up takes way longer than... It's like, if you're gone for a month, you're just logged out of everything, and then nothing works, and it's just like, oh, god. Boop. Alright, cool. So, we have a cyclic quad that divides the thing into 4 triangles. And... Oh, is this one hard? Oh no. KAB. Okay. KDA. Okay, so here's the circles, alright? To circle KBC. Sorry, I meant in circle. KCT. Oh, I'm really out of it today. Oh my god, I can't type. Okay, sorry, that took longer than it should have. And then we have the random arc midpoints, right? So also the arc midpoint. Oh god, how do you draw the arc midpoint? This is a really convoluted way to construct it. Alright, that's fine. Center, B, C, triangle, center, A, B, C, 1, 3. C, D, yeah. I keep hoping there's like a better way to do it, but it might not be without defining your own macro. Okay, cool. We got it. All right, and then okay. So I'm gonna color these circles a different color just so they're a little easier to pick out from. Let's do like orange here. And we'll make these still dark red. Now we have these incenters, so it's like I13 equals segment I1, I3, I2, 4. So you have these like 2 perpendicular segments that all the incenters lie on, which is fine. And then what do I do with I? So okay, so those are all the lines, and I guess we should intersect them. See, the problem is there. Oh god, I need to not have it land on the orange circle exactly. Okay, okay. Thank you, X Creepman, for the sub. Six months. Yeah, so I don't actually know how you control those intenters, like, at all. No, I doubt it. Wait, I mean, we can check at the insiders. I can click. If so, it would be power of a point by K. But yeah, I don't think they're. Yeah, they're not cyclic. Okay. Yeah. Actually, that's good. We can check if OK passes through X. Yeah, it seems like it does. I don't know how to describe X, but yeah, it does seem to lie on line OK. Okay, so that's nice. Okay, so if that's true, then if that's true, I can actually get rid of half the picture, right? Because if the concurrence point is on OK, then what I can do is I can look at just the line for M1, just the line for M2, and then the line for OK. And I claim that these three things concur. And if they do, then I can cyclically repeat the argument, and then everything's great. So I think the upshot of the OK observation is that I can hide half of the stuff in the picture, I want to say. Like I hide I3, I4. And just focus on showing that M1, I1, and M2, I2 meet on the line OK. Which I will. Yeah, okay. So I'm gonna hide 1, 3, 2, 4. I'm gonna just hide the whole. How about I just hide the whole quadrilateral? Okay. D, C. Where's the quadrilateral? Sure. Q1. It's called Q. Okay, so we're gonna gut the whole picture. I'm very sorry, but the triangle is going to be B indexed because that's the way the problem set it up. With my sincere apologies for a B indexed triangle. Shiba, where's D? I do need D for K, but not really beyond that. Why does it look like the in circles touch? They really shouldn't. Yeah, this. I think I need to move D like here, and it will be easier to check. Okay, so in the new picture, ABC is the polygon ABC. And we don't really care about D at all. I mean, so I'll draw in BD, I guess, but it doesn't really matter. And then it's like M1 is this arc midpoint, M2 is the other arc midpoint. We don't care about M3 or M4. That's I1. And it's like I want OK, M1, I1, M2, I2 to concur. So let me draw in. Okay, so I guess if we're down to a triangle, I might as well add in the main incenter, right? It's like the incenter of ABC itself. So I don't know if it'll be super important, but I think it should be in the picture because BI, CI, well, BM2, sorry. Oh my god, the indices, the labeling is horrendous. I'm so sorry. AM2 is one of the angle bisectors, and then CM1 is the other angle bisector. And then, so we have this complete quadrilateral picture. We have this point O. Okay. Okay. Like, X is just really awkward. Yeah, so O, M1, M2, and K, I1, I2. Yeah, so, yeah, okay. So the right angle at K. O is the center of the cyclic quad. So like what else does M1, M2 I1, I2 I1, I2 Actually, yeah, even like if you take K to be the midpoint, it's actually quite surprising to me that this is saying that like the two M lines meet on the perpendicular bisector of BC. That does actually feel kind of strange to me. Really? Okay. Actually, so here's the interesting thing. As I vary the point D, no, never mind, that's false. X seems really well behaved though. I almost want to say X is moving on a circle. I don't know. Some projective or complex. Yeah, I think complex does work. Because what you do is you set up the... it's a little annoying, but like... There's a quadrilateral setup. I forget exactly how it goes. but then I1 is like AM2 intersect B something. So you can compute the coordinates of I1, compute the coordinates of I2, M1, M2. Actually, you only need M1, I1, and intersect it against OK. Do I want to do that? Not really. But if you have an hour to kill, I think it will work. I just feel like it's like, I don't know. I feel like M1 I1 feels like really unnatural to me. Like the green lines feel like there's a trick to them or something. Like it doesn't. Don't silly complex bash. Does anyone remember the? Oh frick! There's something about curvilinear in circles that's supposed to be true, and this is like the section of the book that I never use, so I can never remember what the statement is. But if I draw in the, I'll draw the bottom arc midpoint. All right, so we'll complete this picture. Wait, huh? Where'd he go? Oh, Shipa. It's AIC. Ah, oh, fuck. The indexing's gonna give me every time. Okay, apparently I already named them something. Oh, I see. You want the North Poles? Not the South Pole? Huh. Okay, in the extreme case, when D is all the way at C, it's like K equals X equals... It approaches C here, approaches B here. What's going on in between? No, wait, curvilinear is the wrong one. These are just normal in circles. Oh fuck, I don't. So it's interesting because like when I vary k/d, that point m1 actually remains fixed. It's like I1 and I2 are varying along the blue lines, and I want. Oh, actually, so this might actually be more projective than I thought, because it's like I1 and I2 vary on the blue lines in some relation, and you want their intersection to. Wait, okay, I have to think this through. So I fix k. Why is O involved? Like what? Why are kx? Why does O play any role in here? I think if you're gonna bash, we should just use complex. You want center k and x-axis. Oh god. I don't. That sounds really rough. So I know that I happen to know offhand that like I think I1 I2 meets line AC at some nice point. I think it's the. Oh, that's not what I thought it was. Never mind. Well, actually, okay, maybe the coordinate batches is not. The Cartesian batch is not that bad. What do you do with I1? Is the, like I1 is moving there? Wait, I actually don't see what's going on. Can we just complex it? Uzbek is a 5-problem comp. Oh. Oh no. Okay, that's fine. No, but like knowing it lies on line okay feels like it's worth a lot. Like, cause then you only have to look at like 2 of the in circles at once, and so it's like it's a triangle geo now instead of a quadrilateral geo. However, holy shit. is x? Can you plot the locus of x? Yes, I can. I think it's a circle, like, passing through A and C. But, it looks like that. I can... Maybe if I stretch B, it'll be... Actually, it doesn't even depend on... Hang on. No, it's a little elastic. I don't know. What do you guys? Do you think that looks like a circle? I feel like it looks like a circle. M1, M3 is parallel to I1, I3. Yeah, I believe you. Because M3 is like this arc midpoint here, right? And then... Well, yeah, M1, M2, because... So I1, I3, like the point is that it's the angle bisector of, like the line between the two red things. Are you telling me I have to actually bring M3 back? If so, I would be really sad. Okay, Okay, maybe it is the hang on, maybe it's the North Pole. No, it's not that point. But if I believe that it's the... What is that point? So if in this situation it becomes a flat line, and then if I stretch it down, it looks a little more circle-like, but I can't tell where the center is. But the center is going to be... It's going to be really high up. Yeah, I don't know what the hell that point is. But let's confirm whether it's the locus is really a circle. Ooh, no, that looks far off. Okay. Okay, anyways, alright. Okay. So much for that. Yeah, it's not a circle, apparently. It's off by a little bit. Yeah. I might just complex patch it because I don't actually see what I'm supposed to do. This will be my first time doing not first time, but it's been a while since I've had to do the quadrilateral arc midpoint setup. But I think that's what this problem is calling for. Alright, anyone remember how this works? or just, yeah, I'm sorry, I don't think I'm gonna get this. Okay, let's see. So a squared, b squared, z squared, d squared. So square, 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 square. And the cyan arc midpoints, which is the ones that I care about, are minus, minus, plus, minus. Yeah, okay. I don't really want to do it, but I don't see. I don't, because I really don't want to bring I3 back in because like I don't feel like it's that. Well, okay, I don't mind bringing the other two arc midpoints back in because I don't want to bring the other two incenters back in. Arc midpoints I don't mind because it's like then it's the statement that what like IK1 is parallel to M1 M3. I think that's fair. Like that's okay. In fact, let me draw this in. So KI1 is segment KI1. And then M13 I think we drew somewhere. Actually, okay. Okay, let me just... This might be very messy, but I'm going to draw all of these in. So I have these two perpendicular angle bisectors that look like that. And then I have these... They're parallel to these two other perpendicular lines. That look like that. And then also like BM4, BM3. What the heck? I don't even... Is this gonna be some shitty Pascal or something like that? If I do like... Okay, 1, 2, 3... So blue, cyan, blue... Wait, how does this work? Oh my god. Mother... Oh, huh, that's interesting actually. You're telling me if I flip... I might... Oh. if I flip the location of M4, it's still true apparently. If I use X centers, okay, yeah, we'll force this true, okay. But when I do this calculation, what happens if you replace M1 and M2 by the two other points on the same perpendicular bisectors at equal distances from O? Wait, what? Let's see. Adding in the other incenters reduces showing two homotheties are the same. Alright. Add in the other incenters. I just... Okay, so what homotheties are... So, okay, you're saying that, like there's an M3, I3, M1, I1. And the claim is that that homothety obviously has center on... Why is that clear? So I say I1, I3 is parallel to M1, M3, and there's homothety at X that does it. Oh, okay. The point is, the claim is that you want to try to ditch O. So it's like the... I just feel like the other incenters are so... Ugh. Fine. I'm gonna say just for the record right now, if this was a contest, I would definitely have started complex a long time ago, because it's just, I don't... The complex you can already... I think I can kind of see the complex has to work, like, fairly nicely, because there's just not that much happening. Okay, so I drew all the cyan lines, and it's like, X is the center of homothety mapping I1, I3 to M2, M1, M3, and also I2, I4 to M2, M4. And the claim is that you want these things to... XM1. You want them to have the same homothety center. But they're not the same homothety, because you can see from the picture the ratio is completely different. It's possible to completely classify the intersection point. I mean, yes, that would be really nice. Yeah, but it's the problem is like it's not the same homothety. Like okay, I can see the perspective that it's... If you do I1, I3 to M1, M3, then it's not obvious to me a priori that the homothety center is supposed to lie on line OK. Even though I1, I3, like... And for it to lie on line O and OK, it's almost saying that I need to push like M1, M3 all the way out, so that like that you do the homothety even further. So here's let's say I2, I4. It's like I2, I4 has homothety at X, which maps it to this point. Or wait, now I'm confused. XKO arc linear, right? I just didn't draw that line. And you would need to map M to M4 to something even like some diameter. Yeah, the same center homothety. I just like, because the problem with this is that it's no longer obvious a priori. Like you need an extra. Your conclusion is one dimension stronger, because I don't know. It's like you want 2 points to be the same. Whereas the advantage of like the two whatever. It doesn't matter. Of a two consecutive thing is like if you can get okay M1 I1 M2 I2 to line up, you're okay. No pun intended. Whereas if you can get it for 1 3 and 2 4, the symmetry does not carry it all the way through. Even then. That being said, like okay, fine. Like I think the fact that it's a center of homothency is probably worth noting. It's just not the same homothency. Japanese rectangle thing. So the Japanese rectangle thing is about like the four incenters I and the okay. Those form a rectangle. That is a true statement. But I don't Okay. So I guess it is true that the sides of that rectangle, like if I drew the other four incircles of the big red triangles, they would line up. I think they would be parallel to the same stuff the blue stuff is. Then there's the question, does that help me? Like I can draw in the, you know, there's the other one. No. Yeah, so the oh boy. I feel like the factor of 2 is not particularly good here. Okay, fine. I will, for the sake of having a comedically complicated looking diagram, I will draw in every incenter that's in play, because that seems to be the trend. Oh, these are blue. So there should be 8 of these, right? 1, 2. So I also need AM3 and CM4. Anyone know if there's like a nice variant of Pascal for octagons or something? Ooh, okay, so now we're gonna make this incenter not special because we're apparently doing it this way. So we'll call this one IB because it's the one with top triangle IB. And then similarly, every pair of blue lines also gives, like, here's IA. And the Japanese theorem says that if I draw on the other, okay, so IC should be this one. And wow, I can't believe I'm doing this. Wait, something's wrong. Shit. Something's definitely wrong. Ah, shoot, Shiba. Okay, there's IC, and ID is this one. Okay, so the Japanese theorem promises that IC, ID is a rectangle. And in fact, it's a good rectangle because it's also like everything's parallel. So there's like 3 different lines that are going in this way, and then 3 different lines that are going in this way. This is all Russian 2010 11.3. Oh god. That actually okay. The fact that it's not Russia 4, makes my life makes me a little more hopeful that something dumb like this might work. Okay, and this is Russia 3. Okay, so it's not just murder. Because if it was just destruction, it would be Russia 4 instead. How long have I spent on this? It's 9 p.m. Yeah, okay, I just want to nuke it. I'm sorry, but I don't think I'm going to get this in a reasonable amount of time, so I'm just going to nuke it. Okay, so k is going to be equal to a squared. I'm sorry, I would like to solve it synthetically too, but I just don't think I'm going to get it without like taking up the entire stream, so we're just doing this. So there's k. Let me make sure the compiler is on. And then okay, so if we do the arc midpoint setup that was advertised, m1 is equal to minus ab, and m4 is equal to shit, did I do plus 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 minus or something? The blog post? I forgot already. The thing is, the weird thing is I'm only going to use 2 of them. So honestly, it doesn't really matter. We'll just use minus AB and plus AD, I guess. It won't... Am I breaking the symmetry if I do this? We'll do minus AD. Fuck it. We'll make the both minus. Which you can do if you use the left half. Okay, so the end center I1 is then equal to some intersections. Oh, I see the issue. Okay. Fuck. Wait, no. What? Hang on. Okay, so I need M1 and then 2 other marked midpoints. And by permuting the labels appropriately, only one of them is plus in the setup that I described. So we can just make them all minus. And then the symmetry at the end might look a little strange, but that's okay. So I1 is the intersection of AM2 and BM4. So a squared. Oh god, I'm way too old for this. Holy shit. A squared minus BC and minus B squared. M4 is minus AD. And A squared minus BC minus B squared minus AD. So I wonder if I don't really need to know. So if I'm going complex anyways, do I care that the intersection's on OK? Will that make it easier for me to guess the intersection? I feel like it might not. Because I would rather have, like, I could just not deal with K. I could just say, here's the equation for M1, I1, like line M1, I1, and then write down the analogous equations. Yeah, so it's interesting because I don't know if it actually saves me any work to know that it's on line OK. Because it's like you... Well, maybe this way I don't have to touch the other arc midpoints. I don't know. Well, let's clean this one up first. So I think this in this thing, a factor of AB cancels, right? So we'll just write this as BD, A squared minus BC. Minus AC, B squared minus AD, divided by... Also, I'm so sorry, I misspoke. K is, equation for K is wrong. It's AC, BD. I computed the wrong intersection. AC... Yeah, because I was looking at that, it's like, it doesn't... Yeah, and okay, so this is why, like, when you look at this denominator is going to factor. That's why I think none of the squares are mattering right now. Okay, so what is the least annoying way to get at what's happening? So... We'll use the giant hammer, alright? We are just gonna take the biggest hammer we have and fire it. So M1, I1 intersect OK. So I hope I remember this formula, but here goes. Bar B minus AP bar C minus D. Minus C D bar A bar B minus AP bar C minus D minus C bar D minus CD bar A minus B. It's A bar minus B bar C minus D minus C bar minus D bar A minus B. Wow, all these years later, I still remember this stupid formula. Ta-da! The joys of being a math contest kid. There's a lot of useful skills that math contests teach, and knowing this formula is not one of them. So, okay, we know this, we somehow still remember this formula, which is great. And now what do I do? I'm gonna compute m1 minus i1, okay? It seems like that quantity shows up more than once. So a minus a, it's like minus ab minus this piece of junk. And, oh lord, guys, are you actually checking my work? Because if there's a mistake and no one points it out, I'm not going to notice it either. Okay, please tell me anything cancels out in this thing. Nope, psych. Alright, AB squared D is, oh no. Okay, fine. Guys, I'm old. Does anyone want to do this for me? Really? Nothing. This thing, nothing cancelled. That's kind of bad luck. Really? Really? Nothing? Does it at least factor? Like if a equals... Okay, wait, I should be able to see this from the picture actually. So we can go back and ask like, when are the points m1 and i1 the same point in the GeoGebra? And there should be an answer to that. m1 equals i1 if a equals b. Ta-da! Okay, so that means in the algebra, there should be a factor of a minus b in here. I just need to, I'm gonna want to pull it out. So a minus b... Okay, so it's like this term and this term give me... Wait, really? Hang on. If a equals b, then there's a c... Wait, hang on, something's really wrong. This is degree... I should compute the thing in front of c, right? C is like minus a squared b. Okay, so this is plus b squared minus a squared. No, something's wrong. So m1 should equal i1 if a equals b, was what I just said, right? And if a equals b, then this expression for i1... Oh, sorry, no, there's a c in front of here. I'm stupid. Okay, so this is plus a squared b... No, plus a squared b plus ab squared. Okay, so I flipped a sign somewhere here. Shiba. Kids, help me out. Holy shit. I'm too old to do this myself. It won't cancel. This is a squared b plus ab squared. One of these has to be minus for this to be plausible. And then here there's the other coefficient is b squared d plus ab b squared d minus a squared d. So that one is correct. So is it this one? No, hang on. Motherfuck. I hate this. I am so bad at calculation. B squared M4 A squared minus BC. That's fine. I haven't even gone into the big expression yet. This is just the left half of the page. And then okay, so I had what did I do? I dropped this, so it's like B squared A. I canceled out AB. So it's like BD A squared minus BC, and then minus A squared BC. No, this is fine, right? It's like AB, BD, AB minus AC. And then this minus I1. B squared CD, this is a minus A squared CD minus B squared CD. So this is fine when A equals B, this is okay. Those things die. And then when A equals B, I'm expecting this to cancel, which it really should. It factors as A. Shit. Okay, I understand. Okay, I understand the issue. Right, okay. So A squared and B squared are different. It's A squared equals B squared causes the thing. So, that's okay. Never mind. Everything's fine. It's a factor is A plus B instead of A minus B. Right. I forgot that A and little b are the square roots. Okay, everything's great. Never mind. We're fine. Everything's good. Okay, so the factorization is this thing. So the C stuff comes out and you get B minus A, which is fine, and then the other thing, and then the stuff that only has D in it with no C term. Oh, okay, great. Everything's good. All right, easy clap. Okay, now for the annoying one. M1 bar I1 minus. Well, actually, let's bust this thing. All right. Okay, so because I don't actually care about, I want this to be fixed. So I don't really care about the scalar multiple of k. That doesn't really matter. What I want is this giant fraction here without the k and without that stupid O minus 0 term. So I'm going to just delete the O's because the O's are all 0. So it equals this thing, and then okay, so we just computed M1 minus I1, which is supposed to factor because this is A plus B factor. So we can put that in directly, and and the beauty of this is that I might not even need to simplify the kn, because M1 minus I1, like this thing has a lot of symmetry to it, and you know I think the thing will just do what I want. Let me back that claim up. So this is 1 over A plus 1 over B. Oh, and then let's see which ones are plus. A plus D minus b minus c, a, b, c, d. And then 1 over bd. Okay, so alright, so this is the conjugate of that. It's times k, and then we're subtracting off something times k bar, which is the thing I just computed. And then on the thing on the top is a little more annoying, but I hope it is not too much worse. So m1 bar times I1, which is this expression, minus m1. Okay, wait, I need to be careful about the signs. So m1 is minus ab. And then, so this is going to be plus AB times the conjugate of that. So, blah, 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 blah. Conjugate, AC minus BD shows up. AC minus BD shows up. Motherfuck. Okay, so it's like 1 over AC, this is going to be a BD, that's fine. This is 1 over B squared. AD. Okay, so I believe this is what you get. And okay, so the first thing is I want to kill off all this like AC minus BD garbage that keeps showing up, because we don't, you know, that this denominator is everywhere. Also, there's an a plus b thing here that will also drop out, so I think I don't care about those either. The thing that bothers me is that k is supposed to be the symmetric thing, so I was like kind of hoping this denominator would be mostly symmetric and I wouldn't have to touch like the vet content of k itself. Looks like I'm not that lucky. Okay, that's fine. We'll just factor everything out. Okay, so we'll take out the okay, I think everything becomes plus. Okay, and then so I'm going to cancel an AC minus BD and move this fucker in here, and then plus AB times this thing, and this is like 1. Okay, so as a sanity check, this is degree 2, this is degree 2, and then on the bottom, k is a degree 1 expression, so this is degree 0, this is degree... Shiba. Something's weird. Denominator should be degree 0, so why did I get something with such high degree? Okay, this expression here is degree 2. Alright, sorry, k is degree 2. So this is degree 1 plus 2 minus 2 is plus 1, and then this is 1 plus 3 minus 2 is degree 2. Okay, so something weird happened here. M bar minus I1 should have been degree minus 2. I think I failed at taking this conjugate. Okay, yeah, this is degree minus 2. And I pulled out a plus b. Okay, so this is 1 plus 1, 2... Wait, what the fuck? Okay, this is degree plus 2, which is what I want. 1, 3... Oh, this is degree plus... Hang on. Okay, here it's degree 0, and here it is minus 1, 0, minus degree 0. Oh, I just copied the a plus b for 2 times for no reason. Yeah, stupid. Yeah, okay, so something feels weird to me here, though, because I really wanted this to... Like, this is almost symmetric. Okay, it's not quite symmetric. There's some... It kind of flips a little bit depending on... Yeah, okay, it's not quite symmetric. Okay, fine. Okay, we're fine. Yeah, so unfortunately I think I have to plug k in, which I was hoping I wouldn't have to do, but I think I do have to. So let's pre-compute the conjugate of k, which is pretty... It's actually it's actually quote-unquote the nicer of the two things. So it's like d squared plus b squared minus a squared minus c squared over... Okay, so we need to simplify the denominator, and we need to simplify the numerator. Numerator doesn't have a k in it anymore, the denominator does. But the denominator, I think, is actually the more symmetric one. So let's just run it over. Oh shit, do I have to expand? Oh god, if I have to expand, I'm in trouble. Okay, so the conjugate of k was the thing that I just... Oh, fuck. Stick this in the cast when. Honestly, I mean... I don't know. I feel like if I'm going to complex bash it, I should at least, you know, complex bash it properly. Because I want to show that this is not... I want to show that this solution is actually doable for instructional reasons. Even though... Fuck, that's going to be 16 terms. Holy fuck. Oh no. BCA plus D. And like, there's gonna be a ton of like you can already see this has a lot of factors of whatever it's called. But this AB this little AB here is what's gonna really break the symmetry, because if you ignore the AB, this thing is basically BC AD symmetric, right? You have like a B plus C stuff, you have A D stuff. K is yeah AC BD. Wait, really? Oh no, okay, actually the symmetry is just fucked. Never mind. Because this is A minus C. This is AD. Oh lord. Okay, well, we'll take a vote on this, alright. What do you mean server not found? Oh, there we go. Alright, cool. I'm sorry. This is actually I was expecting something like 10 terms, which I can actually do. But I'm really old, so I don't think I can do like 16 minus 6. I don't think I can do 16 terms minus 16 terms. If it was on paper, I might be able to do it. But I think like trying to type it in LaTeX on these slides is going to be... Okay, cool. That's actually unanimous. Okay, we'll just factor... Alright. Okay, so... Okay, the denominator is actually fucked. So the numerator factors beautifully, which is what it's supposed to do. I don't think the denominator does, and I think I messed something up there. Oh, that's a plus sign, not a minus sign. Still not... This is why you don't complex. I feel like... I don't know. I'm always too optimistic now. I'm just like, oh, this can't be that bad. And I'm like, oh, fuck, I'm an old person. This is terrible. Alright, what did I screw up? Oh. Okay. Oh, that's a lot worse than I thought it would be. Okay, so when you do this thingy, so the inner thing actually is not. I thought it would factor a lot better than this, but the inner thing is actually like 12 terms. This is not good news. I mean, it's fine. It is what it is. Yeah, so the fact that the top factor is this way tells you what factors should be in the bottom. Like, you know that... Like, actually, to be honest, I think I made a mistake because I underestimated the bottom. You should definitely factor the top first because the factorization of the top will tell you what factors need to appear in the bottom. Namely, everything that's not symmetric, so like literally everything. So you know that the bottom will have a factor of AB minus CD, A plus B, A minus B, A priori, and you can divide it out, and it turns out the thing you get is actually pretty bad. It's like this whole thing here. Yep. Okay, sorry, that was uneventful. Has it really been an hour? Has it? I don't think so. I started it at like a little past 9 Eastern, right? So I think it's only been on the order of like... okay, we can check this. Actually, you know what? Presumably, okay, if you're listening to this, probably you're watching the YouTube video. And if you're not, I think you can still rewind in this thing. So someone figure out how long it took if you all care, but I don't think it's been an hour. I feel like I'm not that slow now, but anyways. Okay, whatever. I don't, anyways. Alright, good job. We did it. Very satisfying. This is also going to be like the most anticlimactic write-up ever because it's just literally going to say like, here's the complex bash and then this is what we do. Yeah, what was I trying to do? Right, I need to do the write-up. Also, did someone say that this came before Uzbekistan, right? Because if this is an earlier source, we should credit the first source. Russia 2010 11.3. I mean, it doesn't matter. Okay, so yeah, right up. So then standard formula. Dun, 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 dun. Yeah. Hence. Alright, and then what else do we pre-compute on the slides? It doesn't matter. Well, we show the 4 lines concur at all in line OK. For this, it suffices to prove that OK, cap M1, and appeal to a suitable symmetry. Okay, so okay, so the numerator can be is short enough to be computed first. Wow, and that was a Russia 3? Jesus Christ. Okay, I'm just gonna actually. So okay, we should at least get rid of the dumb factors. Okay, so I'm gonna copy the next thing that we had. Before the Wolfram. Okay. Okay, you know what? I'm gonna make the statement make sense. I really don't like the way it's written right now. Okay. Okay, where was I? Right, so we want to compute this fucker first. And, you know, Wolfram A minus B. I should put a C dot in front of the K bar. Okay, so it turned out to be minus A minus B, A plus B, AB minus CD over AB. Easy. What's more painful? Let me know. There's some lovely implicit factors. Okay, so alright, how about I just copy this? Okay, so we took out the A plus B, but the other factor is like still. Wait, what did I do? This is before I took out the AC minus BD? Okay, that's fine. And then, so the main thing is there's a big factor in front of the... Is that right? So the degree check should be so this was supposed to be an expression of degree 1 plus 2 minus this degree 1. This is 2, 6, 6, 1. Yeah, so that's fine. Thus. Okay, so it's like this giant blob is the main. Must be A plus B. So AB minus CD. AB. Okay, that was an experience. Yeah, and this thing is indeed real, and it has the symmetry I care about. Where if I switch... I don't know, man. Yeah, whatever. Okay. Okay. And this is why you don't complex. Alright.